Hello everyone and welcome to lesson 15, a workflow presentation part 2, assigning parameter values to collected elements and creating custom node. In this lesson, we take over the workflow from where we left off in the previous lesson. In the lesson 14, I described the workflow and steps, and we ended up having all our elements in our example collected. In this lesson, we are going to assign the values from our list to the work breakdown structure parameters. I try to explain each line as much as I can, and now let's get started. Alright, if you remember in the previous lesson, we left off with this Python node having all the elements collected, which were walls, doors, and windows. Now we start with the new Python node. I have already imported all the classes and libraries that we need. I have additionally added this line here. You don't need this one because it includes actually in this line when you import all the functions, classes, and enumeration. So I'm gonna leave it for now. It doesn't matter, and let's start our Python code. First of all, we need two inputs. The first one, I'm going to name it elements. And since we are calling them from Revit, we are going to unwrap them. And this is our first input. And the second one is our list. Now let's add another input. The first one is our elements that we collected here, and for the second input we need a code block, and here I have actually written down my list. My list of values. That's because, as you remember, we determined the values of work breakdown structures of 3 of them as the same value for each element. So we are going to add them. Let's go back to our Python. And now we need to unpack safely our list. I'm going to write down the lines and then I'm going to describe it. We're going to say underscore in values 0 if the length is an argument values greater than 0, else that would be an empty value. Let's copy this one and paste it a couple of times. I'm going to rename them. First and second one. First and second one. Alright. Here it means that these lines actually read the first 3 items of the values from our list that we provided here actually. And it is saying that if an index doesn't exist, list is shorter, then assign empty string. So it means that if we end up with a complete list of 3 values, then it returns our values. If we are going to have 2 values, this third one would be an empty value, and so on and so forth. Alright. Now for the fourth parameter, which is this one, and we are going to assign the level of each element to this work breakdown structure. We need to define actually a helper function. Alright, that's how we do it. We are going to say def get, I'm going to name it this function get underscore elements underscore level name. Alright, and we say category equal from the element, give me the category name, the attribute of the category, we are looking for the name, and we say if the category name has the walls as a name, then we are going to grab the enumeration of the level parameter of the walls. We are going to say level underscore param from that element, give me this is the method how you get the level parameter, get underscore parameter, and as an argument asks for the enumeration name of the built-in parameter. We say built-in parameter, and this is wall underscore, of course this is a little bit tricky, wall base underscore constraint. Alright, since we are using conditions, the built-in parameter, enumeration of built-in parameter for the door and windows is different from the walls. I'm going to say elif category in. I'm going to make a list of my doors and windows. In this case, this is the again the method how we get the enumeration of our category. Parameter, and of course it is built-in parameter, but in this case is the family underscore, not this one, level param. Alright, else If we don't have any of these enumerations, then return n/a. But if you find it, then we're going to get the element ID of the level. So I'm going to name it level. From the current document, we get element, and as an argument, of course, we are looking for level from ID that returns the element ID. As an argument, asks for nothing. In this case, return the level name if level has a name, else return n/a. And if not, return n/a. What we did here actually is a helper function that gets element level. These lines define a function that extracts the level name of an element. For example, for walls, looks at wall underscore base underscore constraint, which is the wall's base level, and for doors and windows, looks at family underscore level param. If neither applies, returns an A, and if the parameter exists, gets the level element and returns its name. Now it's time to assign the parameters to the values to our parameters. So for that reason, we get out of the function, and we start our transaction by saying transaction manager dot instance dot ensure in transaction, and as an always, we feed our current document as an argument. Let me create some space here. We need basically an empty list of our results. I'm going to name my empty list like results. All right, and we're going to use for loop command. We say for el, because we defined it here as an argument, in elements, which was our first input. I'm going to use try and except. Try this first by saying through conditional format. If the lookup parameter of the elements and as an argument asks for we provide the name of our parameter. Then we are going to set the value that we have provided here. And this is the method how you set the parameter. Set, and as an argument we provide the extracted value from our list. I'm going to copy these lines here and paste it a couple of times, because for the first three parameters is the same. Actually, this is our third parameter. This is how we actually fill out the three first parameters. Now we need to assign automatic level to work breakdown structure 04. For that, first of all, we need to get the level name. I'm going to name it level underscore name. And we use exactly what we added here. I'm going to copy and paste it. And again, in this case, work breakdown structure 04. Then we say lookup parameter. We use exactly the same logic that we used earlier for the other parameters. But in this case, we feed as an argument the level name. Now it's time to add the collected values and add it into our list. We say results dot append I'm going to name it updated as an output message. And format it as a string. By element ID. And then we say except if you don't find it. Let me see, I think Okay. Another message, output message, results. I have no idea why I used upper letter here. We don't need uppercase letter. We don't need that. We say like failed. Format again, element ID. We get out from try and accept and close our transaction manager dot instance dot transaction task done. As an output, we expect results. All right, let me save the Python code here and go back to our Revit. As you can see, we don't have any values for our elements here, and we expect that after having run the Dynamo, all these parameters would be filled out. All right, let's save and run. Let's see which line we got error, line 12. Unwrap element. And again, line 15. Basically, I misspelled here the second input. And now let's save and run. It should work. All right, the messages is updated. Now let's go back to Revit and grab. All right, as you can see, the window at level 4 has the this parameter filled out L4, and the other parameters are filled out by the list that we provided in Dynamo. And if I select the a wall at level 02, as you can see, the this parameter is corresponding to base constraints. It's the same for I believe for each element that we provided. Of course, door, for example, level 3 and level 3. The window at level 3 has the same parameter value as the level built-in parameter. All right, that's it for the first part. And now let's get started with custom node. What I'd like to show you now is some simple steps to create custom node without getting into detail. Probably I make another tutorial for this custom package. I have already created a category here. I'm going to create another test node. we have to select the nodes that we want to incorporate in our custom package. On the canvas, we search for create custom node, and we need to provide a name for it and the description. I'm gonna leave it right now and leave it empty right now, and in the category you can add another category, but for now, since I have just created one, I'm going to list it here, and let's hit save. All right, this is the message that creates creates an error. Let's hit it OK for now. And let's jump into test 01, where we have all the nodes here. Probably the error is here right now. All right, for that reason, I'm going to delete this one, because in this environment we have our especially our input node. And if I leave it all the lines as they are and put it here, all right, we don't get any error anymore. And here we have only one input, which is our list to provide. All right, and if I click here, as you can see, I have another node here, test 01. We can save our custom package. Actually, we can provide the path. I'm going to save it to definitions, save it and close, because it doesn't allow you to close it without saving. Now let's test it out. As you can see, I have cleared all the parameters, the values. Let's go back and hit run again. And as an output, it says updated. And if I select my elements inside Revit, I can see that my custom node is working properly. All right, that's it. I think so far through these tutorials we have covered some useful argument about Python in Dynamo. Obviously it is not all, but I believe it can help to start. Each lesson may not seem individually helpful, but the combination of them may create valuable workflows. I hope you enjoyed this series, and I will be posting more videos regarding Dynamo, Python, Revit, and more related workflows in building information modeling. Stay tuned. If you enjoy, please subscribe to my channel and comment the videos, because that helps to grow, enthuse, as well as learning from you. Have a good day, and bye for now.